after their electron clouds repel each other, and their potential energy, is it going to increase or decrease? Stored energy as they repel, bump against each other. Increase. Okay. The blank complex, that is called activated complex. Ooh, I know Micah can't read that one. Let me do it like this. Let me highlight this answer here. Increases. Then I'm going to write the activated complex is the highest point in the potential energy. Pause. If this is A, this is B, this is C, this is D, which point, Micah Prim, is the activated complex? You really thought that was C?
You really phoned a friend?
What's the answer, Gage?
Huh?
What did you say the answer was?
B, because it's the highest up.
Correct. B is the activated energy. Pay attention. B. So over here, I want you to write activated complex. All right, here we go. The energy required to reach the complex is called the potential energy. Okay, so looking at this. This is your potential energy over here. We're going to color it in a second. Products are higher or lower in potential energy than reactants. What do you think? Products. Do they have more or less potential energy? Less. They're going to have less potential energy than reactants. And are more or less stable. Which one? More. This reaction to the left, because the potential energy is lower for the products and more for the reactants, which means it's decreasing in potential energy. What kind of reaction is it?
Endo.
It's decreasing in potential energy.
Speaking energy.
Exothermic.
Exothermic.
Exothermic. Decreasing.
Yeah.
Decreasing in PE. Okay, questions about that? No? Okay, let's label this a little bit more. Right here is going to be your negative delta. Ooh, that's not delta. Delta H of the reaction. This is your activation energy. And this is your reactants. And this is your products. All right. Questions so far? Next, it says to draw the potential energy diagram shown and label the following: reactants, products, activation energy, activated complex, delta H, and whether it is positive or negative. Here we go. Everybody have this? Can I move? Okay. All right, so when the activation energy is high, the reaction is, oh, that's your 10-minute. Write a pass and I'll sign it. Just grab a piece of paper. Okay. Oh, I got you. I'm sorry. It's okay. What did you got a piece of paper. Okay, here we go. Let's see. Is yours blank right here, or is there a picture there?
It's
Ooh.
blank.
Okay, let's do. No, it's supposed to be. Let's just draw it together. No, sweetie, we have so long.
Oh, thank God.
Yeah.
Yeah, we don't want you to do 1 o'clock.
Let's go.
Okay, we have reactants. On our other axis, we have time. Over here, we're gonna have potential energy. Now, when we draw this one's gonna be like this. Hmm.
So this one.
What's that point at the top of this gonna be?
Activated.
Correct. Activated complex. Yeah, I really wanted to do that, but I feel it in my spirit. Someone's gonna ask, what is AC? Okay. All this energy necessary to even start the reaction is gonna be the what? Think about what I said. The energy required to start the reaction. Thank you so much for having your phone out. Yes, activation energy. Ooh. I know. I just really.
What's that E? Are you good?
Okay, the
Are you
distance
okay?
between these two, the products and the reactants, this is our delta H of the reaction. Okay, the products have higher potential energy than the reactants. You're still on your phone. It's crazy. The products have higher potential energy than the reactants. So let's do this. Products are what in potential energy? Higher or lower?
It's higher.
Higher than the reactants and are more or less stable. Which one is it? Less stable. Is it
Less
endothermic or
stable.
exothermic?
Endo.
Endo.
Endostone. Endo.
Endothermic.
Endothermic.
Mm-hmm. Okay, so peep this. If you have an endothermic reaction, your products, oops, spill. Your products are higher than your reactants. So in this diagram down here, everybody see this right here? Everybody see this? The three at the bottom? Can I move this up or are you guys still writing? Can I move it up?
Yeah.
Okay.
Yeah.
So people,
I don't think that's a.
ooh. Okay. So right here with endothermic, should my products be higher or lower than the reactant? Higher. Okay. For exothermic, which should be higher, products or reactants?
Reactants.
Reactants. Okay.
Reactants.
Now, think about this. These are time and potential energy graphs. If something is going slower, what do you think the difference is going to be? How do you think the graph will look differently? Down, like a steeper down, because your potential energy will go quicker down. Okay, I'm not mad at that. So let's look at this. Slow exothermic. Slow and exothermic. Your reactants are going to be higher than your products. Fast endothermic. This. Faster exothermic. Doop. Doop. That one's not cute. I did a horrible job. Don't judge me. That's kind of what it looks like. Stop judging me. Okay. Okay. All right, here we go. Very good job. Questions, concerns, comments? let's start from the beginning. For those of you who missed the top.